You're welcome to my class again today. Now, we want to look at the identity operators, membership operators, bitwise operators. Before then, I also, the assignment operator, all these operators I told you, these are augmented operators, where you're actually combining assignment operator and arithmetic operators. They are combining two operators together to actually give you a calculation in your source code. Identity operators, the purpose is what? Compare the memory location of two objects. Operators is and is not. So we are going to use that. The membership operators purpose test whether a value is a member of a sequence. Then the bitwise operator perform bitwise operations on integers. And we have the AND operator and the rest of them. So let's go into our PyCharm and see the demonstration of these operators. The augmented operators, using the arithmetic operators with assignment operator. So I'll just say A, assign 10. Then I come here, B, assign 5, right? Okay. So I assign A equals to B, A equals to 10, B equals to 5. Then I can say A plus equals to B, right? Then I come here first. Here I will say print A. And here I will say print B. Now here I can say B plus equals to B, and then here I can say A minus equals to B. Here I will say print A. Then here I will say print A. Here I will say print B. Now, this augmented, now look at it. So A equals to 10, B equals to 5, and then I say print A is going to print 10. Here I say print B is going to print 5. Now here I say A plus equals to B. This is the same thing as saying, let me put it in comments. This is the same thing as saying A equals to A plus B. Right? This is the same thing as saying B equals to B plus B. And this is the same thing as saying A equals to A minus B. So now, in this one, I'm going to print A as 10, and I'm going to print B as 5. But here I'm going to say A equals to, so this assignment, they're using assignment operator. Yeah, this statement is saying A plus B, and then reassign it to the a variable. So this 10 plus 5, which is 15, then reassign it to the memory location of A. So in printing A here, it would be a different value from this first A. Then this one, you are saying add B to itself, that is 5 plus 5, and then reassign it to the what? To the memory location of B. And when you now say print B, it's going to print out 10, right? And then here you are saying A equals to A minus B, which is 10 minus 5. And then reassign that value to A, and then print out A, which is going to be what? 5. So let's execute this and see. Now, can you see? The first one is what? You are printing A, which is 10. The second one is what they are printing B, which is 5. The third one is now the new value of A is what? 15. The new value of B is what? 10. And then the new value of A here is what? 5. So you can see that in my script, which is my code, I am changing the value of my what? Variable. I'm printing out new values for my variable. So that is how you can use this. So you can use the other one, which is multiplication, which is division, with this assignment operator. So this is what you call augmented operator. Identity operators, membership operators, and bitwise operators. So let's look at this identity operator. Compare the memory location of two objects. If they are the same, then it will tell you that it is true or false. All right, so I'm just going to delete this, and then I'll say, so for that operator, I'll just say A equals to B equals to A. Now, let's find out the memory address of A and then find out the memory address of B. So print, to find out memory address, you're going to call your ID function. So ID A, and then print, you call ID, and then supply B to it. So let's find out memory address of A, because A equals to 10 and then B equals to A. So are they carrying the same memory address? So print. Can you see? So the memory address of A is this, and the memory address of B is this. So meaning A and B are carrying the same memory address. So if I now say print A is B, and then I come here, I say print A is not B, what will it give me? So A is B will give me true, and A is not B will give me what? False. So let's execute. So can you see? Memory address is the same. So A is B is true, and A is not B is returning false. That is what? Identity operators. So let's look at these membership operators. So in membership operators, I can say this one now, I can say A equals to cool wazobia, right? So I can put this in a string. So this is a string. So cool wazobia. Then I will now say B equals cool. C, assign wazobia to it. All right. Then I can come here and I will say print B in A. And I come here, I say print C in not in A. All right, so what would this give me? This first one, I have B, which is cool, and I have C, which is wazobia. And here I have cool wazobia. So A is cool wazobia. B is this. So I'm now saying print B in A. This is membership operator, the in and not in. So is cool in cool wazobia? Yes, so this one will return true. Why this one will return false? So the first one return true, meaning B is in A. The second one is returning false. Why? Because C is also in A, but not in is not the value of what is being returned. So if you change this, if I come here and I say print C in A, that will return true. So that will return true. So true, true, false. So not in the true will be false. So that is what this membership is. And you can equally use it for number. Let's say a list. Let's say we have, here we have 20, 30, 40. And then I come here and I simply say 20. And here I say 30. Now I run this again. So print B in A. Yes, B in A will return true. Print C in A. C in A will return true. Print C not in A. So C not in A will return false because C is in A. So it will return this same thing again. See? True, true, false. Now, if I change this one to 10, 10 is not there. So print B in A will return false. See? False, true, false. So that is it. Membership operator. You can use it for both. You can use it for any type of data. So depending on what you have inside that database, and then you want to pull out something. It's actually a query. I taught this in my SQL language tutorial, right? For membership. So membership operator, this in and the not in membership operator. Okay, so the last but not the least operator that I want to show you now is the Bitwise operator. So let's remove this and then B equals, so for A, let's assign the, say 25 to A, and then we assign 10 to B. So the Bitwise operator also have the Bitwise and the Bitwise or and the Bitwise exclusive or, right? So let's see the Bitwise and what it will do. So when I say print A, B, what will it give me? See, AB will give me 8. Now, how did he get this 8? All right. So the first thing it will do is convert this operand into binary. To convert 25 to binary, convert 10 to binary, then it will now do apply this bitwise AND to it, which is just like the logic AND. So let's see. This 25 in binary, what will it be? And 10 in binary, what will it be? So what are we going to use to check? So I will call the print function, and then I will call another function, which is the bin function. The bin function, then I will supply A to it, and then here I will call the print function, and then I will call the bin function, and then I will supply B to it. Okay, so when I execute this, what will it give me? And then, okay, let me now print bin, call the A and B. So what will it give me? So when I execute this, now look at it. So binary AND is giving me for 25 is what? One, the OB shows you is binary. So OB means that is for binary. That is the symbol for binary. So looking at this, we have 11001. And this one is 1010. That is for 10. And now it's giving you the value for 8. 8 is 1000, 4 bit. Now, how is it doing this? So this one will be, if you are using the 4 bit, so 1, 2, 3, 4, 5. Now, since this one is 5 already, So let's just increase it to 8 bit. So this one will now be, if you look at this one, so this one will now be 1, 2, 3, 4, 5. So this one will be 0, 1, 0, 1, 0. So the first one is this. Look from your right hand side, you look at the bit from the right hand side. So this first bit is 1, while the first bit of A is 1, the first bit of B is 0. So 1, 0 for AND operator, both of them should be 1 for it to be 1. So 1, 0 will give you 0, 0, 1 will give you 0, 0, 0 will give you 0, 1, 1 will give you 1, right? So that is what he's doing. Then 1, 0, which, because for you to complete this other bit here, you are just going to put 0 in front of it. As we are going to do it as 8 bits, since this one is already 5. So the last one will now be 1, 0 will give you 0. So you now have 1, 0, 1, 0, 0, 0, and that is 8. That is how it got the 8, right? Because for the AND. Then if I change this one to OR, if I change this one to OR, the symbol for OR is a pipe, which is this pipe on your keyboard, this pipe. That is the symbol for OR. So when I change this one to that pipe, and then I print it, what will it give me? You see, 27. So the first one is 1, 0, 0, 0, 1. Now if I add 0 in front of this B, just to complete that bit, I add 0 in front of this B just to complete that bit. Now it will be like this: 1, let me put it in a string for you to see. So 1, 1, 0, 0, 1, right? The next one, the other one will now be 0, 1, 0, 1, 0, just to complete the bit, right? So just to complete the bit, I had to introduce this 0 here just to complete the bit. But in this situation, since this one has already gotten to this, let's, instead of using the 4 bits, let's use 8 bits. So this is 1, 0, 1, 2, 3, 4, 5. So add 1, 2, 3. So that completes 8 bits. Then this one will now be 1, 2, 3. So that completes 8 bits. All right. Okay, so this one was actually in 4-bit form. So I'm just going to make it 8 bits by adding this 0. It doesn't change anything. Now, this one is, if I'm to convert this back to print, right? And then comma, I'll supply the base 2, and then close this. Then this one, I'll say print, and I'll supply the base 2 in binary. So I want to convert this. So the int, because I want to convert it back to integer. So if I'm to print this, what will it give me? So you can see that this is actually giving me my 25, and this one is giving me my 10. All right, so it means that in binary, this is actually, because I'm using 8 bits. So this is it. Now, how is it now giving me this 27 when I say the OR? Okay, so how is it giving me the 27, which is print bin A, print bin B, and then print bin this one, which is the OR. That is the printing this one is 27. How did he get it? So here, you know, 1, 0 will give me 1. That's how it's giving me this one. 0, 1 will give me 1. 0, 0 will give me 0. 1, 1 will give me 1. 1, 0 will give me 1. So that is how you got this one, which when you convert it to decimal is what? 27. So that is how it did this. Print A or B will give us 27. And bringing it, this is how it did the conversion using the truth table of OR, just like the logic operator, the logical operator. So we have the logical and the logical OR. Now this one is bitwise and bitwise OR, because this bitwise is actually used at the hardware layer. That's what I'm saying. It's actually used at the hardware layer. The hardware layer, I mean, because it's dealing with converting it to 0 and 1 and then bringing out your output for you. So this is what I have to show you in the operators. There are many more, but what I'm actually trying to teach you is the concept. So once you have understood what we've done here, you can apply this same knowledge of the concept to every other operator. And then the last thing is what? Operator precedence. Just like we have in BODMAS, operator precedence. So in your code, you have to now understand which of the operator has the highest precedence. And then based on that, when you see a combined operators in your source code, you know which one the Python interpreter is going to work on first before the other one. So operator precedence is what I'm going to show you in my next class. So till then, bye-bye.